Welcome back, everybody. Ready for another deep dive?
Always.
Awesome. Today, we're heading straight to the centers of galaxies.
Ooh, sounds exciting.
I know, right? To the supermassive black holes that we think are kind of running the show there.
At the heart of it all.
Exactly.
Yeah.
And get this, a lot of them, we're finding out, are hiding.
Hiding in plain sight.
Yeah, seriously.
Wild, huh?
So we've got this brand new research from NASA, hot off the presses, and we're going to be diving into that.
Oh, nice.
And we're going to be pulling some info from the NuSTAR mission itself, all about these hidden giants, these supermassive black hole.
I love it when we have missions like that that can really give us that deep dive.
It's fantastic.
It's remarkable.
Yeah.
We used to think that just a small fraction of these supermassive black holes were actually obscured. Maybe less than 15%.
Really?
Yeah. But this new research, using data from both NuSTAR and the veteran, got to give it props.
The OG.
Yeah, the IRA's telescope.
Which launched way back when.
1983. Suggests that that number is actually much higher, closer to 35%.
Okay, so that's a pretty big jump.
Yeah, it's significant.
But I think before we kind of get into the nitty-gritty of all that, we should probably rewind a sec.
Yeah, good idea.
Just so everybody's on the same page.
A little black hole 101.
Exactly. So for anyone listening who needs a refresher,
A little recap.
can you give us a super quick rundown on what supermassive black holes actually are?
Sure. Imagine, if you will, taking all the mass of billions of suns and crushing it into a space smaller than our solar system.
Whoa.
That's the kind of extreme density we're talking about here.
Intense.
The gravity of a supermassive black hole is so strong that nothing, not even light, can escape its grasp.
That's insane.
And we think that these incredible objects lurk at the heart of almost every large galaxy.
Wow.
And they play this really, really critical role in their structure and evolution.
So not your average black hole. These are the heavy hitters,
heavyweights, yeah.
the big guys. And we're saying that over a third of them are concealed behind clouds of gas and dust. Why does that matter? Like, why is that such a big deal?
Well, it really challenges our understanding of how these black holes grow and how they impact the galaxies around them.
Yeah.
I mean, think about it. If they grow by pulling in all this matter, all this gas and dust, wouldn't we expect a lot of them to be, shrouded
Yeah, makes sense.
in the stuff they're eating?
Yeah, like a messy eater.
Exactly. And so this finding, it gives us a much clearer picture of that whole process.
So the more we find that are hidden, the more it kind of supports this idea that they're constantly growing and evolving.
Exactly, yeah.
Okay, so how did scientists even figure out that so many black holes were playing this cosmic hide and seek?
Right.
It's not like you can just point a telescope up there and be like, oh, there's one.
Gotcha. Right.
Yeah.
It took some really clever detective work
Yeah.
and a combination of different telescopes.
Oh, cool.
So remember IRAS, that telescope from the 80s we were talking
Yeah,
about?
the OG.
That one.
Yeah.
It was actually able to pick up on this infrared glow given off by all that hot dust and gas that's surrounding these hidden black holes.
So think of it as like their dinner making a bit of a mess.
Yeah, like leaving some crumbs.
Yeah. So IRAs basically tipped us off that something interesting was going on.
Gave us a clue, pointed us in the right direction.
Oh, okay. So it pointed the way.
And then NuSTAR, which is a much newer X-ray observatory,
Okay.
came in to provide, like, the X-ray vision.
Oh, cool.
We needed to actually see through those obscuring clouds and confirm what IRS was hinting at.
Wow. So they worked as a team across decades.
I love that.
Yeah. To unveil this hidden population.
Okay, cool, huh?
Yeah, that's awesome. Okay, so we've got ancient telescopes giving us clues,
It's amazing how that works.
and then modern ones being like, yep, you're right.
Confirming, yeah.
So let's talk about why knowing the real number of hidden black holes is so important.
Yeah,
Does it change how we understand galaxies? Like the way they work?
absolutely. It really does. You see, these supermassive black holes, they can influence star formation in their galaxies.
What?
Yeah. So as they pull in all this material, it gets super, super hot.
Okay.
And it blasts out all this energy that can actually push away the gas and dust that's needed to make new stars.
Whoa, so it's kind of like a push and pull.
A little bit, yeah.
Right.
So knowing how many black holes are out there, even the ones we can't see directly,
Yeah.
helps us understand how they're shaping the structure and the stars in these galaxies.
So it's like a cosmic balancing act.
Kind of, yeah.
Too much black hole activity,
Right.
and you end up with fewer baby stars.
Potentially, yeah.
Wow, that's wild. It's incredible how something so massive can have such a subtle influence on things.
It really is, yeah.
So it even affects us, right? Here in the Milky Way.
It does. We have our very own supermassive black hole right at the center of our galaxy.
We do. I always forget that.
It's easy to forget. It's not like we can see it,
Right.
but it's there.
It's doing its thing.
And some scientists think that without its influence,
Yeah.
our night sky would actually be way more crowded with stars.
What? Really? So many more stars.
Yeah, it's crazy to think about.
That's wild. I guess it's a good thing we have our own supermassive black hole, kind of keeping things in check.
Right. Someone's got to do it.
Yeah. But I'm curious, so we've found all these hidden black holes.
Yeah.
Does that mean we've solved the mystery of how many are out there? Like, is that the end of the story?
Well, not quite. See, some galaxy formation models, they actually predicted a more even split
Okay.
between hidden and unhidden supermassive black holes, like a 50-50 split.
Oh, okay.
And this new research is a huge step forward, but at 35%,
Yeah.
we're not quite there yet.
So even though we've uncovered a whole bunch more, there might still be even more hidden black holes out there than we realize.
It's definitely a possibility.
Wow.
And, that raises some pretty interesting questions.
Yeah, it does.
Like, what else are we missing?
Right. And what other secrets are hiding out there in the darkness?
Exactly. Makes you wonder, like, what else we don't know, right? What else is out there lurking in the darkness?
For sure.
We've made such incredible progress in understanding these things.
Mm-hmm.
But every time we find something new, it's like,
More questions pop up.
exactly, more questions than answers.
Yeah.
Take the formation of these supermassive black holes.
Oh, yeah. Good one.
Like, we still don't fully get how these things came to be.
That's right. We've talked about how they grow.
Yeah.
But how they actually formed in the first place, their origins.
Big mystery.
It's still this big mystery.
Totally.
So what are some of like the leading theories
Yeah, good question.
about how these supermassive black holes first formed?
Well, there are a couple of really compelling ideas out there.
Okay.
One theory suggests that they formed directly from the collapse of these just ginormous gas clouds
Wow.
way back in the early universe.
Yep.
So imagine like a cloud so dense and massive that it just imploded under its own gravity. And that created like a seed,
Okay.
a black hole seed
Yeah.
that eventually grew into a supermassive giant.
So like a cosmic seed that sprouts and then grows into something huge.
Exactly. But there's another idea out there that suggests that maybe they started out smaller,
Okay.
maybe as remnants of the very first stars.
Oh, interesting.
Yeah, so these smaller black holes would merge with each other,
Okay.
pulled in surrounding gas over, billions of years.
Yeah, slowly but surely.
Gradually bulked up into the supermassive black holes that we see today.
So it's like a cosmic feast with black holes merging and snacking on gas to get bigger.
I love that analogy. Yeah, it's a great way to put it. And actually, this new research that we've been talking about
Yeah.
with the higher number of hidden black holes,
Right.
it actually kind of leans more towards this idea of growth through mergers and pulling in stuff.
Okay.
Because if black holes are constantly snacking, it makes sense that they'd be surrounded by, all this dense gas and dust.
Right. Yeah.
And that would make them harder to see,
Oh, interesting.
especially in visible light.
Right.
Yeah.
So the more hidden ones we find,
Yeah,
the more it points to them being active and growing over time.
exactly.
So it kind of paints this picture of them like evolving over these massive timescales.
It really does.
But it makes you wonder, right, if they're so important to how galaxies actually develop.
Right.
What would the universe look like without them?
Whoa, that's a big question. That's a really thought-provoking one. It's hard to say for sure,
Yeah.
but it's likely that galaxies would look way different without that strong gravity from a supermassive black hole.
Yeah.
They might be way less structured, more spread out.
Okay.
Maybe they wouldn't even have those beautiful spiral arms or those swirling clouds of gas that we're used to seeing.
So instead of these like, really well-defined galaxies,
Right.
we might just have something way more chaotic and less organized.
Yeah, possibly. And the rate of star formation would probably be super different without the black holes kind of regulating things.
Yeah.
Who knows? Maybe galaxies as we know them wouldn't even exist at all.
Whoa, that's crazy. So a universe without galaxies as we know them,
Yeah,
all because of these missing black holes.
potentially.
It really makes you think about how important they are.
It does. It puts it all in perspective, doesn't it?
Yeah, it really does. I gotta ask, are there any other big mysteries about black holes that keep you up at night?
Oh, tons.
Yeah.
There's the whole question of dark matter and dark energy,
Oh, yeah.
which, make up most of the universe.
Right, the vast majority.
And we still don't even know what they are,
Yeah.
but it's totally possible that black holes are interacting with them in ways that we can't even imagine yet.
Okay, so my mind is officially blown.
Yeah.
We've got these powerful objects that we can barely even detect. They're shaping galaxies.
Wow.
And they might be messing with forces that we don't even understand.
It's mind-boggling.
It really is. It's both humbling and inspiring at the same time.
Totally.
It's a good reminder that we're just starting to figure things out
Yeah.
when it comes to the universe.
We're just scratching the surface.
But speaking of figuring things out, we got to talk about the technology that's made all these discoveries possible.
Absolutely.
NuSTAR has been a game changer
For sure.
when it comes to understanding, like, all the high-energy stuff happening out there.
It's like having a new set of eyes to
Yeah.
see through the cosmic fog.
And see all this cool stuff.
All these hidden objects.
It's incredible to think that a telescope launched, what, like a little over a decade ago,
Yeah, just over 10 years.
is already teaching us so much.
It's amazing.
And what about IRAs? Like, it blows my mind that data from a mission launched over 40 years ago
I know.
is still relevant.
It's incredible.
It's still useful today.
It really speaks to the ingenuity of the scientists and engineers
Yeah.
who build these amazing missions.
Yeah, for sure.
And it shows just how valuable it is to have these long-term data archives
Right.
and to collaborate.
Mm-hmm.
It's like we're standing on the shoulders of giants.
That's a great way to put it.
Each generation of astronomers adding to our understanding of the universe.
It's beautiful. It's a beautiful testament to how science actually works.
It really is.
But before we get too lost in contemplation, okay, so I think it's time to bring it all back.
Yeah, good idea.
Back down to Earth for a minute.
Back to reality.
Yeah. And recap what we've learned about these hidden black holes.
Okay.
So it seems like the universe is just teeming with them.
Yeah, absolutely.
Potentially even more than we ever thought possible.
Right, more than we ever imagined. And
Yeah.
you know what? The fact that so many of them are hidden, it really is crucial to understanding, like you were saying, how they grow,
Mm-hmm.
but also how they shape the galaxies around them.
It's like, it really does paint a picture of this kind of dynamic relationship
Yeah.
between the black holes and the galaxies.
Right, this interplay.
Influencing each other over billions of years.
Like a cosmic dance.
Yeah, with all these intricate steps that we're only starting to kind of figure out.
It's a beautiful thing.
And thanks to, missions like NuSTAR and these incredible advancements in technology,
Yeah, the tools we have now.
we're getting a much clearer view of that dance than ever before.
Absolutely. And who knows what else we'll find out there.
Right. What other secrets the high-energy universe is hiding?
It's so exciting.
It really is. Okay, but before we wrap up today, I want to leave everyone with a final thought to kind of chew on.
Ooh, I like it.
So we talked about how important black holes are
Right. Crucial.
to the structure of galaxies and how they evolve.
Yeah, definitely.
But what if they weren't there at all?
Whoa, that's deep.
I know, right? Like, imagine a universe
So-
without these crazy, enigmatic giants shaping the cosmic landscape. What do you think it would look like? That's something to think about, right?
It is. It really sparks the imagination.
Yeah.
It's a good reminder of just how much we still have to learn about this incredible universe.
And our place in it.
Exactly.
Well said. So keep looking up, everybody.
And dig exploring.
Keep asking those questions.
That's how we learn.
And maybe, just maybe, you'll be the one to unlock the next big secret of the cosmos.
You never know.
Until next time.
See ya.